to learn Unit 7 Atoms and Molecules. In this lesson, we are going to discuss about atoms and molecules, atomic mass and molecular mass, about gram atomic mass and gram molecular mass, meaning of Avogadro hypothesis of gases, application of Avogadro hypothesis, atomicity of a molecule, and relation between vapor density and relative molecular mass, relation between the volume of gas and the number of molecules present in it, and concepts of mole. And we are going to solve some problems using mole concept and percentage of composition of a compound. We all know whatever we see around us is made up of matter. Matter is made up of atom. Atoms of same element or different element combine to give you a molecule. So, first scientific theory of atom was first proposed by John Dalton. In his theory, there was some incorrect. So, the scholars like J.J. Thomson, Rutherford, Bohr, and Schrödinger made a conclusion and they removed some limitations in Dalton's atomic theory and they gave a new theory known as modern atomic theory. Here, some postulates of modern atomic theory is given. The main postulates of modern atomic theory are as follows. Atom is no longer indivisible. You all know atom cannot be divided. Atoms of same element may have different atomic mass. Atom of different element may have same atomic masses. Atom is no longer indestructible. Atom may not always combine to form a simple whole number ratio. Atom is the smallest particle that can take part in a chemical reaction. Mass of an atom can be converted into energy by using the formula E is equal to mc squared. First, we are in 7.1 in your textbook. We are going to see atom and atomic mass. Individual atom, for an individual atom, we cannot find a mass. So, macroscopic materials can be measured by using kilograms and grams. See, mass of an atom can be measured by using a unit called atomic mass unit. Here, you all know already, as I told you, atoms are the building blocks of matter. According to the modern atomic theory, atom contains subatomic particles like protons, neutrons and electrons. And the number of protons and neutrons together we say it as a mass number. Mass of an atom can be measured, as I told you now, it is measured with a atomic mass unit. Atomic mass unit is 1/12 of mass of carbon-12 atom, that is an isotope of carbon. Next, coming to the relative atomic mass. In the early days, scholars, that is chemistry scholars, used to measure atomic mass of an atom, that is relative atomic mass of another element. By using one element, they found out the atomic mass of the other element. They measured the atom of two or more elements at one time. They kept one element as a standard and in this way they obtained relative atomic masses. In the beginning, hydrogen was kept as a standard element. Later, oxygen was kept as a standard element and at last, nowadays we are using carbon-12 as a standard element. So, to say about the definition, relative atomic mass of an element is a relation between the average mass of the isotope of 12th part of the mass of carbon average atomic mass, how we can measure atomic mass of an element. So most of the element occurs in an isotopic mixture. Most of the elements around us are made up of isotopic mixture. Each having the same mass. It is essential to consider isotopic mixture while calculating the atomic mass of an element. So average atomic mass of an element is weighted average of masses of its naturally occurring isotope. Abundancy of all these isotopes are taken into a consideration while calculating the atomic mass. So how to calculate the average atomic mass? We have to product the mass and the percentage of abundancy. So average atomic mass AMU is equal to percentage of abundancy of the element into mass plus other element, that is abundancy of that element into mass. So you can get an average atomic mass. A problem is given to here. Silver occurs naturally into two isotopes, that is silver 107 and silver 109. So guys, the abundancy of this silver is, the first silver is 51.8% and next silver is 48.2%. How you can calculate the average atomic mass of this silver mix? So AAM is average atomic mass is equal to percentage of abundancy into mass plus percentage of abundancy into mass. So after finding the product of these elements, you have to add, and average atomic mass of that silver is 107.9 AMU. Next, coming to the molecule and molecular mass. So what is molecule? It is the combination of two or more atoms held together by a strong chemical forces of attraction through with the help of a chemical bond. So how you can classify the molecules? If the molecule is made up of a similar kind of atom, then it is called as homoatomic molecule. Molecule that consists of atom of different element, it is called as a heteroatomic molecule. The number of atoms present in the molecule, we call it as an atomicity. Here, some atomicity of some atoms are given here. If the atomicity is 1 means you call that atom as a monoatomic atom. If it is 2 means diatomic, and if it is 3 is triatomic, and more than 3 means it is polyatomic. Here some examples of homoatomic molecules and heteroatomic molecules is given here. So for example, homoatomic molecule, first oxygen. Oxygen consists of 2 atoms. So you call this as the homodiatomic molecule. So in ozone there are 3 atoms of oxygen is present. So you call this as a homotriatomic molecule. So coming to the examples for heterodiatomic molecule, here 2 different atoms are there. One is hydrogen and another one is chloride. So hydrogen and chloride gives heterodiatomic molecule because here different atoms are there. is mole concept? What is it? If you have two items in your hand, what you will say? It is pair of object. Scientists used to measure atoms and molecules, they used a unit called mole. So that only we are going to discuss now. What is mole concept? The study of collection of particles by using mole as a counting unit in order to express the mass and volume of such unit particles in a bulk of matter is known as mole concept. In SI system, the mole is the amount of substances. The mole consists of some substances that contains as many elementary entities like atoms, molecules and some particles. As there are atom is exactly, which is compared to the 12 gram of carbon 12 isotopes. For 1 mole, its value is 6.023 into 10 to the power of 23. You call this as an Avogadro number. So, how you will calculate moles for atom? 1 mole of an atom contains 6.023 into 10 to the power of 23 atom, and it is equal to its gram atomic mass. How you will calculate mole of molecules? 1 mole of matter contains 6.023 into 10 to the power of 23 molecules, and it is equal to its gram molecular mass. This 6.023 into 10 to the power of 23, it is called as a value for 1 mole, or it is called as a Avogadro number. This is named after a scientist, Italian scientist. This number is named after an Italian scientist, Avogadro. So, to calculate the number of moles of a substance, we need some data. We need some data to calculate it. So, what are the data we need means the number of moles of molecules, number of moles of atoms, number of moles of gas, that is standard molar volume at STD, that is 22.4 liter, number of moles of ions. These are the data we needed to calculate the number of moles of an atom or molecules. So, if you want to calculate the number of moles, first we need mass. What it is given, we have to see. If it is given mass and the atomic mass of a substance is given means, we have to divide mass by atomic mass. So, we will get the mole. And if it is mass and molecular mass is given of in a particle, then we have to calculate mass by molecular mass, that gives you number of moles. Number of atoms by 6.023 into 10 to the power of 23. If atom is given means, we have to calculate the number of moles like this. Number of atoms by Avogadro number gives you a number of moles. Number of molecules by Avogadro number. That means, if to calculate the number of moles, what you have to do is, number of molecules by Avogadro number, if we divide and see this, we will get the number of moles. So, next comes percentage composition. What is meant by percentage composition? Percentage composition of a compound represents the mass of each element present in 100 gram of a compound. Percentage composition of oxygen and nitrogen by taking the example water. Now we are going to know percentage composition of water. Here a problem is given to find the percentage composition of water. First, mass of an element, that is mass of that element, that is water. Element in the compound by molecular mass of the compound into 100. Now, we have to know, first we have to find the molecular mass of water. So, H2O, how many atoms are there in water? 2 atoms. So, what is the molecular mass of hydrogen? 1. So, 2 into 1 is 2. So, what is 16? This is the molecular mass of oxygen. So, 2 plus 16 gives you molecular mass of water, that is 18 grams is molecular mass of water. Next, now we are going to find the mass percentage of hydrogen alone. So how many molecular mass is given in hydrogen? 2 by molecular mass of water, what we already found, that is 18. We have to put down and we have to multiply it with 100. So you will be getting 11.11%, that is mass percentage of hydrogen. Now we are going to calculate mass percentage of oxygen. So what volume and N is the number of molecules that is present in a gas. Whatever the gas you take, the number of molecules that is present is considered as N. Then Avogadro law you can represent mathematically like this. V is directly proportional to N. So V is volume and constant into number of molecules that is present in the gas, whatever the gas you take. The volume of gas is directly proportional to the number of molecules of the gas. Once again, I will repeat you. Avogadro law states that equal volume of all gases under similar conditions of temperature and pressure contain equal number of molecules. Next, application of Avogadro law. Where we can apply this Avogadro law? It explains Gay-Lussac's law. It helps to determine this. Avogadro law helps us to determine the atomicity of gases. Molecular formula of the gases can be derived using the Avogadro law. It determines the relation between the molecular mass and vapor density of a particle. It helps to determine gram molar volume of all the gases. These are the applications we are. With the help of the Avogadro law, we can find the Gay-Lussac's law. We can determine the atomicity of gases. We can calculate the molecular formula of gases. We can find the relation between molecular mass and vapor density. And it also, this Avogadro law also helps us to determine gram molar volume of all gases. Next, relationship between vapor density and relative molecular mass. First, we have to know the definition of vapor density and relative molecular mass. What is relative molecular mass? We have to keep hydrogen scale as a constant. The relative molecular mass of the gas or vapor is a ratio between mass of one molecule of gas or vapor, any gas or vapor, to mass of one atom of hydrogen. Next, what is vapor density? Vapor density is the ratio of the mass of certain volume of gas or vapor to the mass of an equal volume of hydrogen measured under the same conditions of temperature and pressure. We can write the vapor density like this also. Mass of the given volume of gas or vapor at the STD, that is standard temperature pressure, by mass of the same volume of hydrogen. Next, according to Avogadro law, we are going to find the relationship between vapor density and relative molecular mass. According to Avogadro law, equal volume of all gases, already we saw it in the law, equal volume of all gases contain equal number of molecules. Let the number of molecules is 1, then volume N is Vd, that is vapor density at STP. Mass of N molecules of gas or vapor at STP by mass of N molecules of hydrogen. So first we have to cancel N now. When you cancel N, what will happen? It is considered here as 1. So vapor density is equal to mass of one molecule of gas or vapor at STP by mass of one molecule of hydrogen. Since hydrogen has two diatomic atoms, it is a diatomic atom. So we can write like this: mass of one molecule of gas or vapor at STP by mass of two atoms. So hydrogen consists of two atoms of hydrogen. So we have to remove one and we have to write it here, two atoms of hydrogen. Now we are going to compare the formula of vapor density with relative molecular mass. They can be represented as mass of one molecule of gas or vapor at STP, 2 into mass of one atom of hydrogen. So relative molecular mass is mass of one molecule of gas or vapor at STP, mass of one atom of hydrogen. Now you can substitute the equations. After substituting, you will be getting vapor density is equal to relative molecular mass by 2. Now cross multiplication we have to do. 2 into vapor density gives you relative molecular mass of gas. At the end we can write relative molecular mass is equal to 2 into vapor density. So this gives you the relation between vapor density and relative molecular mass. Now we are going to calculate molecular mass of water, carbon dioxide, calcium phosphate. First we will see how to calculate molecular mass of gram molecular mass of water. So here the solution is given for you. Atomic masses of 1. So oxygen contains only one atom here. So 16 into 1 is 16. So 2 into 2 is 2 and 16 into 1 is 16. When you add up, you will be getting gram molecular mass of water, that is 18 gram. Here atomic mass, we are going to find the molecular mass of carbon dioxide. So atomic mass of carbon is given you 12 here and oxygen is given you 16. Now we are going to find out gram molecular mass of carbon dioxide. So already atomic mass is given for carbon is 12 and oxygen is 16 is given here. So only one atom of carbon is present. So you have to multiply 12 into 1 plus you have one oxygen. So oxygen is O2 here. See, carbon dioxide, 2 atoms of oxygen is present. So 16 into 2 is 32. So when you want to add up 12 plus 32, you will be getting 44 grams. So gram molecular mass of carbon dioxide is 44 gram. Next, we will find gram molecular mass of calcium phosphate. So the hint is given for you here. Calcium is 40, phosphorus is 30 and oxygen is 16. So we are going to find the gram molecular mass of calcium phosphate. So here first we have to see how many atoms of calcium is present here. 3 is present and oxygen is 4 present here and only one molecule, only one atom of phosphorus is here. So calcium's value is given as 40 into 3 and phosphorus is 30 and oxygen is 16. So how many atoms of oxygen is there? 4 atoms of oxygen is there. So we have to multiply 16 into 4. 16 into 4 give you 64. So 64 plus 30 will be getting 94. 94 into 2 is 188 and 40 into 3 is 120. 120 when you add up with the 188, you will be getting gram molecular mass of calcium phosphate. That is, you will be getting 308 grams. So gram molecular mass of calcium phosphate is 308 grams. Next, now we are going to calculate percentage composition for sulfuric acid. First, calculate percentage of in sulfuric acid. We are going to calculate sulfur percentage. Molecular mass of H2SO4, that is sulfuric acid. First, we have to find the molecular mass of H2SO4. So, what is the molecular mass of hydrogen? It's 1. So, hydrogen consists of 2 atoms. So, 1 into 2 is 2 and sulfur, it is 32 molecular mass. How many atom of sulfur is there? Means only 1. So, 32 into 1 is 32 and oxygen, it is given you 4 there. So, molecular mass of oxygen is 16. 16 into 4, it is 64. When you add up this, you will be getting 98 grams.